This video is on work when the force is not constant, but rather variable. This graph shows a force changing smoothly and continuously depending on where the mass is. Depending on its position, the net force on it is different according to this equation right here, 3/2 x squared. Several rectangles are shown in this picture. We'll get to those in just a minute. Part A, what feature of this graph will give us the work done by the force between x equals 0 and x equals 4 meters? We can look at the units and say newtons on the vertical axis, meters on the horizontal axis. What is the unit for work? It's newtons times meters. So the area under the graph is going to give us the amount of work done. We can approximate this answer by dividing the graph into rectangles. Here, each rectangle's height is the force at the 0.5 meter displacement. And what is each rectangle's width? So if we look at the picture here, we can see that the width of each rectangle is 1 meter for this particular example that we're doing. Using these rectangles, let's calculate the approximate work that's done. We're going to want to use this function, and there it is. And we're going to want to find the force at 0.5 meters, and then the force at 1.5 meters, and then the force at 2.5 meters, and the force at 3.5 meters. And then for each of those, we're going to multiply those heights by the width, which is 1 meter, and then we're going to add those up. That's going to approximately give us the amount of work that is between 0 meters and 4 meters. And you can see that the reason that works is because you see this little basically triangle right here that we have added in additionally by using the rectangle we have. Well, that is approximately equal to this little essentially triangle up here that we have forgotten to add in. And same thing with all of these others. Let's see what kind of an answer we get when we do this. 3/2, and then the x value is going to be 0.5. We're going to square that, and then we're going to multiply by the width, which is 1. That's the first rectangle. Now let's do the second rectangle. 3/2 times the x value of 1.5. We need to square that because that's what the function says, and then multiply by the width, which is 1 meter. Let's keep going for these last two rectangles. 3/2 times the x value of 2.5 meters. Got to square that. Now to find the area of that rectangle, you got to multiply by its width. So let's put a 1 in there. Not quite done yet. We got one more rectangle. 3/2 times the x value of 3.5. Square that. That's what the function says. Multiply by the width. If we add all of those up, that will give us the area of these 4 rectangles. And you feel free to check me on this, but when I did this, I got 31.5. Now what's going to be the unit on there? It's going to be newtons multiplied by meters, which is the same as joules. So that is the area between 0 and 4 meters whenever we use these 4 specific rectangles. Letter D. Our exact, precise Part A answer could be found if we did what with regard to these rectangles? If we had an infinite number of rectangles and each of them had an infinitesimal thickness of dx, that would give us the exact amount of work that's done. Now, how do we do that? We integrate, don't we? So let's go ahead and do that. That's what we're going to do here in Part E. We're going to find the exact precise work done by the force between x equals 0 meters and x equals 4 meters. So here we go. The work that's going to be done is going to be, shall I write out the basic equation first? How's that? That's the definition of work. Now let's put in what we have. Our limits of integration in this case are from 0 to 4. The function that goes along with the force is 3/2 x squared, and then we have to put our dx in. And so we're just going to integrate that. When we integrate, we need to power up. This power is going to go up to 3, x to the third. Then we're going to divide by that new power. Well, when we divide by that new power, the 3's will cancel, and we'll just end up with that 1/2 still sitting out there out front. And we need to integrate from 0 to 4. We're going to put 4 in here. We're going to cube that, and then we're going to cut it in half. 4 cubed is 64 divided by 2, 32. Hey, you know what? That's pretty good. Our estimate wasn't bad. Look at that. The estimate up there at the top, and when we actually found the area, it was 32. Whenever you have a varying force, you cannot use just the simple work is F dot D. That equation down there at the bottom only works when the force is constant. If the force is varying, you have to do something like what we showed here.